What if I told you the most valuable substance in the universe isn't gold, diamonds, or even rare earth metals? It's something so exotic, so powerful, that just 1 gram could fuel humanity's energy needs for centuries. But here's the catch. It doesn't exist on Earth. In fact, it barely exists anywhere in the observable universe. Today, we're diving into the mind-bending science of antimatter. To understand antimatter, let's start with the building blocks of reality. Matter. Everything around us, planets, stars, even our bodies, is made of atoms. Atoms consist of protons, neutrons, and electrons. But antimatter is the mirror image of ordinary matter. Imagine a mirror universe where every particle has a twin. That's antimatter. Identical in mass, but opposite in charge and quantum properties. For example, the electron's antimatter counterpart is the positron, which has a positive charge instead of negative. A proton has S antimatter counterpart called as antiproton, which is negative charge. Even neutral particles like neutrons have antimatter counterparts called antineutrons. Antimatter was not discovered by accident. It was predicted by math. In 1928, physicist Paul Dirac solved a problem haunting Einstein's relativity and quantum mechanics. His equation describing electron behavior had 2 solutions. One for electrons and one for something else. Dirac initially thought it was a mathematical quirk, but that something else turned out to be the positron, the first antimatter particle ever theorized. Dirac later joked, "My equation was smarter than I was." 4 years later, in 1932, physicist Carl Anderson observed something bizarre in his cloud chamber. A particle curving the opposite way of electrons under a magnetic field. This was the positron, antimatter's first confirmed member. Anderson even snapped a photo of its path, earning him the 1936 Nobel Prize. Here's the kicker. When matter and antimatter meet, they annihilate each other in a flash of energy. Pure Einsteinian EMC word in action. A single gram of antimatter annihilating with matter releases energy equivalent to 43 kilotons of TNT, roughly 3 times the Hiroshima bomb. Let's start at time 0. The Big Bang wasn't an explosion in space. It was the rapid expansion of space itself. In the first millionth of a second, temperatures soared to a quadrillion degrees, hot enough to spontaneously create matter and antimatter from pure energy. According to Einstein's E = mc², energy can morph into particles. But for every particle created, an antiparticle must form too. Protons and antiprotons, electrons and positrons. They flashed into existence and annihilated each other just as fast. But here's the puzzle. If matter and antimatter were created equally, they should have wiped each other out, leaving behind nothing. Yet here we are. So what tipped the scales? This is the greatest unsolved mystery in physics. Why does our universe have more matter than antimatter? Scientists call this baryon asymmetry. For every billion antimatter particles created in the Big Bang, there were 1,000,000,001 matter particles. That tiny excess, 1 part in 1,000,000,000, is why galaxies, planets, and life exist. Hollywood loves antimatter. In Angels and Demons, a Vatican-destroying bomb is powered by stolen antimatter. In reality, even a gram of antimatter would explode with the force of a nuclear bomb. But storing that much is impossible today. Antimatter isn't just for sci-fi. Right now, positrons are used in PET scans to detect cancer and heart disease. When injected into the body, they annihilate with electrons, creating gamma rays that doctors can track. If you enjoyed this deep dive, hit like, subscribe, and ring the bell for more mind-blowing science. Let me know in the comments. Should we invest in antimatter, or is it too dangerous? Thanks for watching. See you in the next video.